Alright, so now we are looking at flux. Okay, I'm coming. Flux. Alright, flux, right? So flux is a quantity defined by flow of quantity per unit time per unit area, right? Okay, so flow rate. When you hear rate, what comes to mind? We are measuring a particular quantity with respect to what? Time. So if I have velocity, right, is distance over what? Time, right? So this is velocity is a flow rate, right? Okay, speed. But this one, yeah. So you know these ones. Acceleration, right? Acceleration. Meter, meters per second square, right? So anytime we're having a particular quantity that has per time or per time, meaning that we're having a flow rate there. Are we okay? But in this case, we don't talk about acceleration. We just want 1s, right, per unit time, just one. I just use this as an example. So most of the ones that you've seen in flow rate, you have just 1s at the end, right? So this is speed is distance over time, right? So what if, let me introduce something new. What if you happen to meet something like this, volume per second, right? What will you call this? What will you call this one? Because if we have speed to be distance over time, what will you call this one? So volume per time. This is what we call volumetric flow rate. Okay, so the flow rate may be different. There are different types. So far as we have it's per time, just one time, not squared or anything. So far as it's just one here, okay, meaning we are talking about a particular flow rate. So if it's volume per second, we have volumetric flow rate. Okay, and you're saying that the area is always normal to the direction of the flow. Then again, let me draw this diagram. Remember I said this, like I'm drawing it again. You see something like this. So this were to be a velocity profile where something like this, right? Like this, right? If this were to be a velocity profile, right? They are saying that the area is normal to the direction of flow. So I was saying that this is showing the velocity, right? And the longer it is, saying that the magnitude of that particular velocity is bigger than the other ones, right? Okay, then they are saying that the area is normal to the direction of flow. So this one is showing this particular direction, right? The velocity grade profile is going in this particular direction. The area that we are talking about is this, from here to here. Okay, so they are saying this one means normal. So this area here is normal or perpendicular to the direction of flow, which is this. Are we okay? Yeah. Okay, so you see these are fluxes and then they are units. Okay, so as I was saying, there is not always that we have something like speed, which is distance per time, right? Or which is meters per second, right? So you see these are other ones. Momentum, right? Energy. So you see joules. I was talking about flow rate here, but now they've introduced time. Sorry, area, right? So the flux is flow of a quantity per unit time per unit area. So it's like flow rate per unit area. Okay. So if I were to have, if you come here, momentum, right? So there's the time factor. Energy, there's the time factor, there's the area factor, and there's energy, right? So mass, kilogram, right? And there's the flux, a quantity per unit area per unit time, right? So this is the unit area, unit time, right? Molar flux. So molar, this is mole, right? Flux per unit area per unit time, per unit area per unit time. Are we okay? So it could be any of this. So then again, it could be any conserved quantity. So you see momentum is here, energy is here, mass is here. And when we're talking about chemical species, we talk about moles, right? Yeah.